Alright, so I'm going to work on solving a few things now that we've introduced these rational exponents. So I'll just work on a couple. So remember, a with an exponent of m over n is equal to the nth root of a to an exponent of m. Okay, so I'll start off with something like if I've got 1 over 25 to an exponent of 3 over 2. So this would be the same thing then as 1 over 25, and I'm going to take the square root of that. Okay, and I'm taking the square root because 2 is the number in my denominator, so 2 must be the number in my index. And I'm not going to write the 2 because we don't write the 2 on a square root symbol, and then I'm going to cube it afterwards. Okay, so the square root of 1 over 25, the square root of 1 is 1, the square root of 25 is 5, so we get 1 over 5, and then we're going to cube that. Okay, so 1 cubed is 1, and 5 cubed is 125. Okay, let's do another one. We'll go something like negative 32 to an exponent of, let's say, negative 4 over 5. Okay, so with this one, I got options in how I want to deal with it, so I can do the exponent, the negative portion of that. I can do that last, or I can do it right at the beginning. It's not going to make much of a difference. So if I was to take the negative exponent here, it's going to take everything that's in my set of brackets, and it's going to move it into the denominator. Okay, so now I've got the negative 32 with an exponent of 4 over 5 in the denominator. Now with this one, so I'm still going to take the fifth root of negative 32, and that's fine to take the fifth root of something negative because I'm taking an odd root. Odd roots are allowed to have the negative in there. Okay, so the fifth root of negative 32 is negative 2, and then we still have that exponent of 4 outside, and negative 2 to an exponent of 4 is positive 16. Okay, so I can still work through all of these things. Don't need a calculator if I take the root first. Most of the time it works out nicely. Okay, unless they're telling you that you need to do some rounding. Okay, so we'll carry on. Let's introduce some more variables into this because that's where things kind of start to get difficult. So what I'm going to do is I'm going to try and write everything. I want to write it with positive exponents. We very rarely want to have negative exponents kicking around, so we want everything with positive exponents. And we're going to also write it as a entire radical. Okay, so we'll show both forms. That's not how you spell radical. Let me fix that. Hard to write with this. Okay, so we're going to write everything with positive exponents and as an entire radical. So let's say I've got something like x with an exponent of 5 over 2 and times just x. Okay, so using our exponent laws, we would add those two exponents together. So it'd be 5 over 2 plus 1, and that's going to be x with an exponent of 7 over 2. Okay, so if I want to write that as a radical, because I already have everything as positive exponents, so the 2 being in the denominator means we need to have the square root, and then since everything needs to be under the radical symbol, I need to put my exponent of 7 underneath. Okay, and so there we have it, both as an exponent, or positive exponents, as well as in its radical form. Okay, let's say we've got something like y with an exponent of 1/4 is divided by y with an exponent of 7/4. Okay, so this one, I would need to subtract my two exponents because they're dividing. Same base dividing, so we subtract, and that gives me y with an exponent of negative 6 over 4, and we could reduce that in lowest terms as negative 3 over 2. Okay, but we don't want it having negatives in our exponents, so I'm going to rewrite this. Okay, I'm going to take that, I'm going to move it down here. We're going to rewrite it as 1 over y with an exponent of 3 over 2. Okay, so we simply just write it as the reciprocal, and now we've gotten rid of that negative exponent. Okay, and then we need to write it as a radical. So as a radical, we would have it as 1 over the square root of y cubed, but right now this is a problem because it's not an entire radical. Entire radical means we want everything underneath that radical symbol. Okay, so we would really want to write this as the square root of 1 over y cubed. And since the numerator was just 1, it doesn't make any difference. It can move underneath no problem, because when I square 1, it's still 1. Okay, let's try one that's a little bit harder. Let's see. Let's work with this one. We got 9x with an exponent of 2 over 7 divided by 27 and an exponent of x with x with an exponent of negative 6 over 7. Okay, all right, we got more going on this one. Okay, so we're going to, first off, notice that the 9 and the 27 can cross, or they can reduce, so we get 1 and 3. Okay, so that makes life a little bit easier, having 1 and 3. And then we would have to move this one here. We don't like this x being in the denominator, so we can move it up to the numerator and make it positive 6 over 7. Okay, now if you don't actually want to physically move it, you can still just use your exponent laws. Okay, and think of it as, well, I've got x with an exponent of 2 over 7, and I need to subtract what's in my denominator. And what's in my denominator is negative 6 over 7. So it becomes 2 over 7 minus negative 6 over 7. So that becomes x with an exponent of 8 over 7 over 3. Okay, so there it is as a, where everything is positive. Okay, now if I want to write that as an entire radical, that means I want to put everything underneath the one radical sign. So in this case, I need to have the 7th root of x exponent 8. And in order to move that 3 underneath, it would need to be 3 with an exponent of 7. Okay, and so that's going to be the 7th root of x exponent 8 over 2,187. So there it would be as an entire radical. Okay, let's do, I got one last one for you. Okay, so I got 16 and times a with an exponent of 1/3. And then outside the brackets, we've got an exponent of 3/4. Okay, so with this one, inside the brackets, that exponent of 1/3 is only impacting the a. All right, it's only touching the a. So this one, the exponent of 3/4 is going to go onto everything inside the brackets. Okay, so it's going to go onto that 16, and that's going to be an exponent of 3/4. Okay, and then we are going to multiply that by a, and it already had an exponent of 1/3, so we're going to have to multiply it by that exponent that was outside. And this is actually not so bad. So the 4th root of 16 is 2, so I get 2 to an exponent of 3. Next to that, we're multiplying the 3's, they cancel, so I'm left with a to an exponent of 1/4, and 2 cubed gives me 8. So I get 8 times a with an exponent of 1/4. If I wanted to change that into an entire radical, then I need to have the 4th root, and a is going to just be sitting underneath there. To move the 8 underneath, I would need to go 8 to an exponent of 4, and I did not leave myself enough space. Just give me a second here. Okay, we need to go 8 with an exponent of 4, and that gives us 4,096, and then we've got a underneath there. Okay, all right, not so bad. Now I can also work backwards, right? So we've been taking everything with its exponent and changing it into a radical, but now I can also take any radicals and I can rewrite them as something with exponents. Okay, so something like this, I could take the square root of 625, and I could write it as a power, and if possible, also evaluate it, right? So with this one, it's the same thing as having 625, and we said, well, we raised that to an exponent of 1/2, because we took the square root. But then we took the square root again, so it's like another exponent of 1/2. So in total, it's like 625 to the exponent of 1/4. Okay, now the square root of 625 is 25, and then the square root of 25 is 5. So we can also say 625 to an exponent of 1/4 is 5. And if you wanted to double check that on your calculator, you'd find that it works out quite nicely. Okay. We might also have something like this, where we've got the square root and then we've got a variable involved, right? So the square root of 400, that works out really nicely. It's just 20, okay? And then the square root of x, I could leave it as the square root of x, but if I wanted to write this one as an exponent instead, it would be 20, and then the x would have that exponent of 1/2. Okay, so just changing from a radical into an exponent. Okay. Let's look at a weird one. Let's say I've got the cubed root of, we'll say x exponent 4y squared, and we're going to raise all of that to an exponent of 3/4. Okay, so what I'm going to do is I'm going to take that cubed root, and instead of writing it as a cubed root, I'm going to change it now so it becomes x with an exponent of 4/3 times y with an exponent of 2/3. Okay, and then I've got that exponent of 3/4 outside, and that exponent is going to multiply both exponents that are now sitting inside the brackets. Okay, so that first one, 3/4 is the reciprocal of 4/3, so that one is just going to become x with an exponent of 1. For the second one, the 3's are going to cancel, and the 2 and 4 cross reduce, and I get, well, it's not an x, it's another y. Okay, so we get y with an exponent of 1/2. Okay, so the important thing to remember is just we can change really easily back and forth between radicals and exponents. It just depends which one is easier for you to work with. Again, if you're trying to evaluate these things, make sure you're taking the root first and then raising it to a power after. All right.